When we think of data analysis, we usually picture spreadsheets and charts. But what if I told you it's really just classic detective work? Today, we're going to crack a case, not in a dusty room, but right inside a dataset. We're hunting for clues and solving mysteries one data point at a time. And here it is, our central mystery. It's a question we've all wondered about, right? Does putting in more hours really pay off with better grades? Now, our gut might scream yes, but a good detective never, ever assumes. We're going to follow the evidence and see where the data actually leads us.
Think about it. Every investigation starts with a room full of clues, fingerprints, notes, odd items left behind. The real challenge isn't just seeing all that stuff, it's figuring out what it all means. And that, right there, is the heart of data analysis, separating the raw evidence from the story it's trying to tell.
This really splits the detective's job in two. On one side, you've got analysis. That's the forensic work, dusting for prints, gathering the hard facts. It tells you what the data shows. But interpretation, that's the magic. That's the breakthrough moment. It's connecting those dots to explain why any of it matters.
So, where do we start? Well, a detective's first move is always to bring some order to the chaos. You can't spot a pattern when everything's a mess. In the world of data, we call this descriptive statistics. It's all about getting a simple, clean summary of the evidence right in front of us.
The first tool we'll grab is the mean. It's pretty straightforward. It's just the average of all our evidence. In this case, the average of all the exam scores. It gives us a really quick snapshot, a first glance at the scene.
But, an average can be a little tricky. One really high or really low score can throw the whole thing off. So we also look at the median. If we line up every single score from lowest to highest, the median is the one sitting smack dab in the middle. It gives us a different angle on what's typical.
And our third tool for finding the center is the mode. Think of this as the clue that just keeps popping up at the crime scene. For our investigation, it would be the single most common exam score. It tells us what happened most often.
Okay, so knowing the center is great, but that's not the whole story, is it? We also need to know if our clues are all bunched up together or if they're scattered all over the place. This spread is crucial. It tells us if our evidence is consistent or just totally unpredictable. All right, we've organized our evidence, we've got a feel for the crime scene. Now comes the really exciting part. We're about to take what we've learned from our small pile of clues and make a big, bold prediction about the entire universe of students. This is where we go from just describing the scene to actually solving the crime.
And this right here, this is what I call the big leap. It's the moment of truth for every data detective. We're moving from simply describing what's happening with our little group of students to making an inference, a prediction, about all students everywhere. It's a huge step.
So how do we make a leap like that without just, guessing? We don't. We take our main theory, our big hunch, and we put it on trial. This is called hypothesis testing, and it's basically the courtroom showdown of our investigation.
And just like any real trial, you can't just wing it. There's a formal process, a set of rules you have to follow. First, you state your claim. Then you gather your evidence. You decide on your standard of proof, run the official tests, and only then do you make a decision.
Now, in our courtroom, there are two sides. On one side, you have the null hypothesis. This is the defense. It represents the presumption of innocence. It assumes study time has no effect on scores. On the other side is the alternative hypothesis. That's the prosecution, making the bold claim that study time does affect scores. Our job as detectives is to see if we have enough evidence to overrule that presumption of innocence.
But how much proof is enough proof? Every court needs a standard. In statistics, we call this the significance level, or alpha. We usually set it at 0.05. What that means is we demand evidence so strong that there's only a 5% chance we're seeing a random fluke. We have to be 95% sure before we challenge that presumption of innocence.
All right, so we're in the courtroom. We've got our standard of proof. Now our detective needs to pull out some specialized forensic tools to actually examine the evidence and find those hidden connections. And one of the most powerful tools in our kit is correlation. Think of it like a special scanner that measures if two clues tend to move together. Does one go up when the other goes up? And, more importantly, how strong is that connection? So, we run our correlation test on the data, and the result is a Pearson's R of positive 0.98. Now, on a scale where +1 is a perfect lockstep connection, getting a 0.98 is, well, it's about as close to a smoking gun as you can get. It's an incredibly strong sign that as study hours go up, exam scores go right up with them.
But, and this is a huge but, before we close the case, every single data detective has this phrase tattooed on their brain: correlation does not prove causation. I'm going to say it again. Just because two things are linked, it does not mean one caused the other. It's a massive clue for sure, but it's not a confession.
Okay, it's time. We've examined the evidence, and we're ready to deliver a verdict. But even with the strongest case, every detective knows there's always a risk. There's always a chance you could make the wrong call.
First up, the type I error. Honestly, this is the detective's absolute worst nightmare: a wrongful conviction. This is when we decide there is a connection, that study time matters, but we're wrong. The pattern we saw was just random chance. It's a false positive.
And the flip side of that coin is the type 2 error. This is when the guilty party walks free. It's when we conclude there's no connection, that study time doesn't matter, but in reality, it did. There was a real effect there, and we missed it. A false negative.
So when you look at it this way, you can see there are really 4 possibilities every time we make a decision. 2 of them, we get it right. Awesome. But in the other 2, we make a huge mistake. Either we convict an innocent idea, or we let a guilty one get away. This is the tightrope every data analyst has to walk.
So after all that, what is our verdict in this case? Well, based on that bombshell correlation of 0.98, the evidence is pretty overwhelming. We are rejecting the null hypothesis. The data strongly suggests that more study time is linked to better exam scores.
But I want to leave you with this final thought. We have our verdict, and it's backed by solid evidence. But is any verdict ever the whole truth? What other hidden clues, what other factors could be at play here? The data has helped us solve one mystery, but the best part is it almost always reveals a new one, just waiting for the next detective to come along.